integers, signed and unsigned. Sometimes we know in advance that the value stored in a given integer value will always be positive. So we know that in certain situations that value is negative or positive. Being used to only count things, for example, in such a case we can declare the variable to be unsigned, as in unsigned int num students. So we can declare that variable as signed or unsigned. So example is unsigned int number of students. So number of students is int. With such a declaration, the range of permissible integer values for 16-bit OS. So there are 16 and 32-bit and 8-bit OS. So with a declaration, the range of permissible integer value for 16-bit OS will shift from range -32768 to +32767. 32767 is given because 0 is also included here. So it is up to 67 to the range 0 to 65535. So this is new range now. 0 to 65535, thus declaring an integer as unsigned almost double the size of largest possible value. Thus declaring the integer as unsigned almost double the size of largest possible value, otherwise it can take. So declaring as an integer, it doubles the actual size of possible value, otherwise it can take. Note that an unsigned integer will occupies 2 bytes. This is how an unsigned integer can be declared. So unsigned integer I. So I is an unsigned integer. An unsigned I. So like an unsigned integer, there are also exist a short unsigned integer. So it has a range, long and short. So there also exist a short unsigned integer and a long unsigned integer. So long is also there. By default, a short int is a signed short int and a long int is a signed long int. Chars signed and unsigned, parallel to signed and unsigned integers, either short or long. Similarly, there also exist signed and unsigned chars, both occupying 1 byte each, but having different ranges. So, signed and unsigned chars are also do exist, each having different ranges. To begin with, it might appear strong as to how a char can have a sign. So, it might appear that as how a char can have a sign. Consider this statement: char ch is equal to a. So ch is a char which is equal to a. Here what gets stored in ch is the binary equivalent of ASCII value a. So binary of 65 is stored in char a, and if 65 is binary can also be stored within -54's binary can also be stored, and signed char. A signed char is same as ordinary char and has a range from -128 to +127, whereas an unsigned char has a range from 0 to 255. So these are ranges of this signed char and unsigned char. So this is a basic program. Main char ch is equal to 291. So 291 is a character and it is defined as ch. Now printf /n, that is on the next line, %d %c. So % is for integer and %c is for character. So first ch is integer and second is character. What output do you expect from this program? Possibly 291 and character corresponding to it. Well, not really surprised. So this output of this program is different. So we thought output of program will be 128, but we forgot that a char cannot define take value bigger than 127. So reason is that char ch has been defined as char and char cannot take value bigger than +127. Hence when a value of ch exceeds +127, an appropriate value from the other side of range is picked up. So appropriate value from other side is picked up and stored in ch. So this value in our case happens to be 35, so any random value is picked. So in our case, compiler picked 35, hence 35, and its correspondence character hash gets printed out. So its corresponding character hash gets printed out. Here is another program that would make the concept clearer.